Not my usual, but what I have here is the open back of a Leslie 825 rotating speaker cabinet. It differs from the classic, both in the fact that this amplifier section uses transistors rather than vacuum tubes. The rotating baffle for the speaker is less elaborate. It's made out of polystyrene rather than wood. And there is only one speaker on the tube ones. I believe there's an upper section to the cabinet with a pair of rotating horns. It's working as an amplifier. I've only had intermittent response from the rotating speaker. So I assume that there's something wrong with the dual motor, which is somewhere back here. And it's going to be stuff like rubber parts, lubrication, springs. Mechanisms that are not dissimilar to what I look at in multitrack cassette players. I hope there's some sort of transferable skill set to this. This big wooden panel came off. Long bolts with a recess for a flathead screwdriver and a washer went into those holes, and then we just have ones like this, and that goes 1, 2, I think it was 3, 4 locations. That removes this plate, which is functioning as a housing for, I think that's a phase inverter and these power transistors. So let's see what we can unplug. I guess that's a 12-inch speaker, haven't actually measured it, but that's going to a socket here. I should mention this is high voltage, so I think those are the filter capacitors there, and that's the main transformer and everything there. They could hold pretty nasty voltages immediately after it's been turned off, but charge would slowly dissipate, and it's been, I think, 24 hours since it was plugged in, so I should be safe to touch this at the moment. Disconnect this daughter board. There's a black and red header here. We've got another cable here, blue, red and yellow. I'll need to unscrew this little cable tidy thing in a minute, but we can see that that's unplugged there. This must be the connection to the motor, which is going to be somewhere back there. I know the lighting's not very good, we'll get it out in due course. It looks like if I remove this bolt, then this is going to pull out from between these wooden spacers. That wasn't all that easy to get out. If you look, this bolt is slightly bent. The space in the top for a flathead screwdriver is pretty shallow, besides which this wood's in the way, so you can't get a standard screwdriver in there, so I had to use some kind of combination of pair of pliers and this socket extender thing to get it out. But that seems to be the only thing that's holding that in on this variation of this model. That's holding that there. It's being stopped from wiggling from side to side by this bit of wood and this bit of wood here. This plug has clips on both sides, so those need to be pushed in for it to come out of there. Some of the plastic pins are shaped such that you can't put it in the wrong way. We've removed the speaker. There are 4 bolts of the slot. By tipping that over to the side, you can see I've got this metal bracket, and there's a bearing and stuff in there which may need to be oiled. When this lifted off, which happened after I removed these 2 narrower and shorter bolts, see that there is a little washer that comes with each of those. There was a metal washer and then a little foam spacer underneath it. So these 2 go through here. Underneath that, the metal, and this foam washer below that. Here you can see the polystyrene baffle. That slid out of there after I first removed this upwards from through this hole. You see this little rubber part? That attaches to the baffle via this pin. So I guess that's the main way that it's exerting rotational force to it, like so. But then the bottom part of this, what will I call that, spindle with a pulley on it, is going through this part on the opposite side of the baffle. The lower part of that is revolving and a bearing there. We'll be able to see more clearly in a bit, but the way that the motor drives that baffle is that this thing that looks kind of like the elastic bungee that you would tie stuff to the roof rack of a car, that is wound round there. So that's how the rotational movement of this pair of motors here is transferred to the baffle. But that's something I might want to take out and clean. So we can see there are nuts on this side, but it feels like there's more of this kind of bolt with a slot for a flathead screwdriver on the opposite side of the panel here. Just checking all the parts, make sure that I've bagged them appropriately. What do you think about it, little man? Yeah? Is that good? Is that good bagging by daddy? Oh, it's a good boy. That's not. You're a good boy. I've got the motor out. These little sleeves, they sit in these little rubber bushings. There's a bolt passing through those. These wing nuts are going into them. Maybe in the dark there you can see that there are 2 bolts hanging down here, and they have a little bit of room to move back and forth. I suppose that's just to allow the tension of this bungee cord thing between the motor and the pulley that's on the baffle, so you can adjust that. Look at this guy. This plug is just for 4 cables going to 2 motors that are attached to each other. Let's talk about the function of this a little bit. It would hang this way up, roughly that way round if we're looking in the back of the cabinet. It's hanging from that bit of wood. Bungee rope looking thing is going off from this pulley that I'm tapping to the baffle on the right. But I can actually turn it upside down and rest it on this pulley, which I will do. So really we've got 2 motors bolted to each other, separated by this plate. We can actually remove the lower part by removing 1, 2, 3, 4 bolts. And here you can see there's a large wheel with a rubber O-ring on it, and that is part of the same spindle axle. I'm not sure what the appropriate word is, but it's part of the same bit as this pulley. So you can see when I'm moving the wheel up here, it also moves this, and it's moving the equivalent part to this that I'm tapping with my finger, which is inside this black casing here. And the idea is, in stop position and in the slow speed, the center of the revolving part of this smaller and slower motor is in the position so that the center of it presses against this wheel, and that rotates through this inactive motor and transfers that slow rotation to the baffle, giving us a slow speed. But in high speed, when this is turned off, it works as a solenoid, so that gets sucked up to there, and this pin is no longer in contact with that large wheel, so it doesn't contribute anything to the speed, not even friction. At that point, this motor takes over and the pulley turns at a much higher speed. One other thing that I will draw your attention to, because it was an issue for me, in addition to the entire rotating part having seized, the pressure of this pin against this rotating wheel was too high, and that meant that in the high speed the solenoid really wasn't strong enough to pull this down, so the whole thing kind of panicked and collapsed when I tried to go at the high speed. So I was only getting the slow speed sometimes, and then it was jamming up. So what I had to adjust here is this pair of white nuts on this long bolt. You don't need to adjust that one, that's just a rubber grommet that sits this into this plate here. But effectively by changing this, we change the angle, because that isn't perfectly straight. I hope you can see it's leaning very slightly left, this entire motor assembly, and that's actually changing how much tension there is between that large rubber O-ring and this pin. It was too tight on mine. I've loosened it off a bit now, and as you'll see in the following footage, it does rotate at the higher speed now thanks to that adjustment. So that applies to you. You're getting low speed but not high. I would, as well as doing due diligence like oiling it, changing rubber parts if you can find replacements, conditioning the existing rubber parts with something like MG Chemicals Rubber Renew, then I would try and adjust that. And the way I did it was I set it so loose that this wasn't even touching, and then adjusted it until it's pretty easy to move that away from and onto that rubber O-ring without there being too much friction there, and that seemed to work. Okay, so this is all set up outside of the cabinet, and you can hear that there's quite a lot of buzz. This is just what happens when there's no audio input on this thing. I'll talk about it in a second, but what I'll first show is the location of this pot here. The best thing to do with this is to turn it up as loud as it will go without the input distorting. Now, the way I'm using it, input level is going to be controlled by the output of a preamp pedal. I'll talk more about that in a second. So I can turn it pretty much all the way up. I think if you're going to connect an actual Hammond to it, you would adjust this so that the amplifier input doesn't distort. But just because that noise is horrible, I'm just going to turn it right down for now so that we don't have to listen to that. What I've got here is a Dr. Fish Sticks. It's not super complicated. It's really a way of connecting this generic foot switch for a guitar amp and a couple of audio inputs and the input from the AC and feeding them into this antiquated, I think it's called Apifenol. Anyway, I'll put the actual word up on the screen just now. But it's really an adapter to make jack inputs and a normal plug input go through this cable and up to the amplifier, because the amplifier doesn't have any plug input of its own. It's expecting to take the AC supply from the Hammond organ. Now, I'm not supplying it with the Hammond organ. I'm wanting to put possibly a guitar, but mostly combo transistor organ through it. Leslie had their own product with a preamp built in, but they're pretty expensive and hard to come by. So this guy makes these in the US. I think it cost me about £115, including delivery and import duty and everything for that and the pedal. And then I'm going to be running a cheap Joyo pedal that makes it sound like a Vox in front of it, because Vox Jaguar into Vox AC30 is the sort of tone that I want, but I want to have the Leslie style rotating speaker on it. Cable that came with this was 30 feet long, and that was just completely impractical for me. So I've cut it down to, what's that, maybe 3 feet? But that's just 9 cable in a core with a kind of connector. There's nothing magical or special about it. 2 of those are thicker and contain the live and neutral for the power supply. Some of them are unused, the others are audio and connecting or disconnecting certain pins that's telling this system whether the motor is stopped or whether it's in the slow mode or whether it's in the fast mode. I read in a forum that this works much better if it's actually suspended, so I've just got it on a couple of plastic crates with wooden blocks so that we can observe it. Watch this solenoid part. See how it drops down? When I say it drops down, really it's being pulled down by an electromagnet, and that means that the spindle of that is no longer touching against that big wheel with a rubber O-ring on it. So this motor up here is driving this pulley at a much higher speed. And when I toggle back to it, this motor turns off and this one turns on, but also this is going to return to the up position so its spindle touches the rim wheel. The rim wheel is just at the opposite end of the same axle as the pulley. So this one is quieter and slower. This one, that might be a bit noisy, but it's going to be noisier anyway because it's a higher RPM, right? So if I toggle back down to that again, hopefully you saw that move up. This large wheel with the O-ring is spinning. There's discussion in the service manual about a brake. In my mind, brake implies that there is some sort of friction applied to this in order to slow it down. There is no such thing. It's just the inertia of the spinning polystyrene bit that eventually slows it down to a stop. Friction that's in the system rather than there's some sort of pad touching something, which is what I would think of as brakes from a cassette player, a bicycle, a car. There is a capacitor which takes a set amount of time to charge. It's meant to be sort of 3.5 seconds, so that if you press stop while the motor is spinning in the fast mode, because this is the fast motor up here and there's a slower motor down here and they're just bolted together, then it will enter the slow mode for that period, whatever it is, 3.5 seconds, until this capacitor charges up. And then when the capacitor charges up, another transistor is triggered and then it goes to a dead stop. And then it'll toggle between the speeds. And then if I press the stop from the high speed, it'll drop to the low speed for a few seconds. 2, 3, 4, 5, and then stop. So that's the brake mechanism. I suppose what it's saying is that the lower speed is going to turn the polystyrene baffle for a bit, so it has less momentum, and then when it's turned off completely, its inertia will kind of bring it to a more natural sounding stop. I really want to be able to tear this down as much as possible. The problem that I have here is that there's a nut and bolt here, and the bolts are of this type where you need to use a socket set. The trouble is that the nature of the bracket, it's too thick to get that in. I bought a set of spinners like this, spent like 35 quid on them, and then like realised that these are Imperial rather than metric, and the ones I bought are metric, so I'm not going to spend another 35 quid on a set of Imperial just for this one job. What I'm doing instead is actually just cutting these bolts off. So I've got a high-speed drill with a little, I don't know what the material is, crushed cheap diamond in it or something, but anyway, you can cut metal with it. So I'm getting the sparks to fly into my solder desucker so I don't get too much fumes or particles of metal into my lungs. And then when I put this back together, I'll replace these bolts with roughly the same size. I'll want a hole for an Allen key or a screwdriver, because that'll fit in there no problem. If I hold it at one end with the Allen key or the screwdriver, and then I can use my socket set at the other end, because I do have Imperial as well as metric sockets for this, then I'll be able to tighten it up again, but that's how I'm gaining access. I had to buy a 3/32 of an inch Allen key in order to get this part off. I now have access to the inside of the fast motor. These two caps are identical except for, I think it must be the upper one because of the direction of this writing. It has input wires go to the power supply. It turns out that this part just has brown paint all over it, so I was worried that that was rust, but clearly not. Perhaps these felt parts were dry, or just we needed lubrication in these two parts, but they seem to be the main places within which this is spinning. There is a certain amount of dirt. It's certainly useful for me to see exactly what I am oiling. I'm about to oil the mechanism. I'm using this AMS oil, 0W30, very light synthetic motor oil, which was recommended to me by a former Tascam technician. I'll be applying it in this old Keg Deoxit bottle, just because it's got a needle applicator. You can see there are holes beside the bearings, here and here, by which we can access the felt and the bearings. Well, I'm not sure there's felt, there is in the other ones. On the high-speed motor, these caps off, we can see the felt. So I'll be applying as much as the felt can take, and also in around these areas as well. As I was taking this apart, I lulled myself into a bit of a false sense of security, because the manual seemed to be well documented, well illustrated and so on, but actually this is a case where the territory has changed after the map was made, and the parts that are on this are slightly different to what's described in the manual, so I'll just kind of talk you through that. If we start in sequence, at the top we have this screw and washer, which is going through this pulley into this hole at this end of this part. This part you can see has a hole at this end and two slots, and then no slots but a flattened part. So this is the rim wheel end that goes onto the slow speed motor, whereas this is going through one of these two caps that has the wire through it. This part with two slots is going through there. The space between these parts that I'm tapping with my finger and this slot here corresponds to this bearing here. You can see here I've got a metal washer, then a rubber grommet, and then a big C-clip that's on there. So that's going to be underneath there, and then once that's pushed up through that hole on the far side of there, we're going to put the same sort of configuration. So put on a washer, then a rubber grommet, then another washer. They're going to be sitting just inside this large gap here, and then I'm going to be slotting this big E-clip back on there, okay? So there's going to be like a sort of symmetry to that, where you've got E-clip, washer, rubber, washer, then the bearing of this cap, then washer, rubber grommet, washer, and then an E-clip. And that's just going to sort of sandwich this part here in either side of this cap. And then this little clip is going to go into this slightly shallower indent here before this is slotted on. And then this would be screwed in through the pulley to hold it on tight. Then at the far end, we would put that back on so that this part that's flattened here goes through there. We put the rim wheel back on there and use our Imperial size Allen key to screw into there and to hold it on tight. They're suggesting a 1/16 of an inch space between here and the bottom of that surface.
if you don't have a 1/16 of an inch shim, then I suppose just something like a thick piece of cardboard could be inserted between those two surfaces before you tighten it, and then remove that bit of cardboard. Essentially, they just want to be a little bit of space so that this surface here that I'm tapping and this surface here that I'm tapping don't actually have any friction between each other. Notice as well that there are two widths of thread on these screws. There's 3 like this and 4 where the space between the thread is wider. The 3 are used to attach this plate here, but then the 4 are used to attach the slow motor to these 4 holes in that plate. It's reconnected. I haven't actually shut the baffle. I just wanted to check that it was working before I put in those last set of screws. This is my Wilson hobby organ. Output from that turns off the internal speakers because it's a combo organ. And it's going into the input of this Joyo AC tone, which is meant to sound like Vox AC 30. And then the output of that is going to the input of the Mr. Fish Sticks. The Mr. Fish Sticks is also taking the input of the pedal, as we saw earlier, and the power. And then all of those signals are going through this cable and into the speaker. So the sound of the organ is like that with this on. It's just slightly more driven, slightly more mid-focused, and what I was saying earlier about being able to control the level using the pedal, I can turn that right down. So I'll put the camera over here, record a passage while I am operating the control pedal here, so you can see it go from stationary through to the slow speed to the high speed, back to the slow speed and stationary again. Success! Thanks for watching to the end. Hope this was useful and fun. Like, subscribe, do all those things that makes me an ally of the evil algorithms, please. I appreciate it. See you soon.